Hello students, welcome to our YouTube channel Pratik Singh Classes. Okay, this is the third video for chapter 5 periodic classification of elements and 23rd video in a row for CBSE Standard 10th Science. Okay, in the previous two videos for this chapter we have already seen a lot of things. First we have seen how the early attempts were made to classify the elements known at that time. Then we have seen Doveniers, triads means 3. Okay, so there we have seen that when elements were arranged in an order, okay, every element has the properties and mass average to the first and last, okay, of its predecessor and successor elements. Okay, then examples were given how it happens. Then we have seen some notes about this great scientist Johann Wolfgang Dovenier. Okay, then we have seen section 5.1.2, that is Newland's law of octaves. There we have seen that when elements were arranged, okay, they follow the law of octaves. That means Newland has given that every eighth element has the physical and chemical properties which resembles the first element, okay, and vice versa also. Okay, then we have seen that there were some drawbacks in his table because two or more than two elements sometimes were placed at the same position. Okay, even though the work done by Newland was of great achievement. Okay, then Mendeleev has made his periodic table, which was based on the atomic mass. Okay, he has arranged the elements known at that time by increasing order of their atomic mass. Okay, then some small thing we have seen, okay, about Dmitry Ivanovich Mendeleev as a scientist. Okay, then we also have seen that at his time only 63 elements were known, but when he has made his table, he has given some blank spaces so that in future if new elements were discovered, they can be added at that position without changing or without doing any alteration in his own table. Okay, and there we have seen how Mendeleev has made the periodic table based on the hydrides and oxides of the elements. Okay, then we have seen section 5.2.1, that is what are the achievements of Mendeleev's periodic table. Okay, how he has made the periodic table and what benefits at that time people have got from it. Okay, then we have seen the limitations, that what were the drawbacks of Mendeleev's periodic table, and also when new things were discovered, okay, what were the reasons that his table was rejected. Okay, then there came the modern periodic table. There we have seen that how Henry Moseley has made a new periodic table based on increasing order of atomic mass. Okay, and a lot of other things we have seen. Then we have seen the periodic table, okay, which we follow now. Okay, and then we have to start from today. We have to start from section 5.3.1, that is position of elements in the modern periodic table. Okay, so let us start our section 5.3.1. But before we start our today's video tutorial, let me request to all of you once again, please subscribe and like our channel Pratik Singh Classes, and please hit the bell icon for all updates. Okay, so let us start our today's video section. Okay, that is section 5.3.1, position of elements in the modern periodic table. Okay, so the modern periodic table has 18 vertical columns known as groups and 7 horizontal rows known as periods. Okay, so let us see how it is given in the modern periodic table. Okay, so as you can see in this table, sorry, I am recording this from my laptop, I can't tilt my screen, so you just tilt the screen of your mobile phone to see it. Okay, so from top to bottom, okay, it is called as here groups, and from left to right is period. Okay, so here you can see totally 7 periods are there and 18 groups are there arranged, okay, in the modern periodic table. And addition to that, there are two separate series called as lanthanides and actinides, okay, which were kept separate from this periodic table, which is a drawback in the modern periodic table, but it has its other significance. Okay, it has its other benefits also. Okay, so coming back to our section 5.3.1, Fine. So let us see what decides the placing of elements in certain group and period. Means how do we know that which element will be grouped in which group and which period. Okay. Activity 5.4. Look at the group 1 of modern periodic table and name the elements present in it. Okay. So see in group 1, okay, we have hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. Okay, so these are from top to bottom is called as group and left to right is called as period. Okay, now what similarity do you find in the electronic configurations? Okay, if you write the electronic configuration of group 1 elements, you will find out that the outermost orbit of the atoms have only one electron in that. Once again, if you write the electronic configuration of group 1 elements, you will find out that the outermost orbit of each element has only one electron in it. So that is the common thing. How many valence electrons are present in these three elements? Okay, it is only one electron in the outermost orbit. Okay, fine. You will find that all these elements contain the same number of valence electrons. Similarly, you will find that the elements present in any one group have same number of valence electrons. Okay, so not only for group 1 or group 2. Okay, if you see any other group, you will find out the electronic configuration. Okay, in the electronic configuration of elements of same group, okay, the number of electrons available in the outermost orbit are same. Okay, or the valence electrons are same, and so valency also will remain the same. For example, okay, the elements fluorine, chlorine, okay, they belong to group 17. How many electrons do fluorine and chlorine have in their outermost shells? Okay, it is 7. So as you can see here, where is that? This group 17 elements, fluorine, chlorine, bromine, iodine and astatine. First two we have taken, fluorine and chlorine. Okay, the atomic number is given there 9 and 17 respectively, and if you write its electronic configuration, you will find out that in the outermost orbit they have 7 electrons. Okay, so valence electron is same as well as valency is same. Hence, we can say that the periodic table signify an identical outer shell electronic configuration. So this is a significant achievement or a special property of the modern periodic table. On the other hand, the number of cells increases as we go down the group. Okay, so keep in mind these small things which are of too much relevant. Okay, as we go down the group, okay, suppose we have taken group 8 elements, that is iron, ruthenium, osmium. Okay, so if you go from top to bottom, the number of electrons in the outermost shell will remain the same, but at every next element, okay, one cell will be added. Okay, the number of cell will increase. All right, so once again, the number of cells increases as we go down the group. Okay, there is an anomaly when it comes to the position of hydrogen, because it can be placed in group 1 or group 17 in the first period. Okay, so see what really happens in the position of hydrogen is that the hydrogen can be placed in group 1 as well as group 17 because of its allotropes. Okay, it is available in environment in 3 forms. Okay, and because of that we are still confused where to keep the hydrogen. Okay, now activity 5.5, if you look at the long form of periodic table, you will find that the elements like lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon are present in the second period. Okay, so write down its electronic configuration and find out what is the similarity in them. Okay, so here it is given group 1 group 1 of modern periodic table. In group 1, what are the things we have? Okay, you have to write it down. Okay, Then if you find lithium, beryllium, boron, carbon, C, it is available in group 2 element. In group 2, that is lithium, beryllium, then boron, carbon, nitrogen, oxygen, fluorine, and neon. Okay, leaving out neon, let us write the electronic configuration of all the elements of group 2. Okay. Does this element also contain the same number of valence electrons? Okay, no, their valence electron will increase by one, okay, in each element, and but the number of cells will remain the same. Okay, so just for your mark, okay, as you go from top to bottom, okay, that means in groups, okay, you will have uh, in each next element, the number of outermost orbit will increase. Okay, but when you go from left to right in the periodic table, okay, that means in a period, okay, the number of outermost orbital will remain the same. Okay, you will find that these elements do not have the same number of valence electrons, but they contain the same number of cells. Okay, that means the number of cells remains the same in a period. You also observe that the number of valence cells electrons increases by 1 unit as you go from left to right across a period. Okay, as the atomic number increases by 1 unit moving from left to right in the period. So that is the reason why does it happen. Okay, next we can say that atoms of different elements with the same number of occupied cells are placed in same period. Okay, for example, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon belong to third period of modern periodic table since the electrons in the atoms of these elements are filled in K, L, and M cells. Okay, write the electronic configuration of these elements and configure the above statement. Okay, that what really does the author want to teach you here. Each period marks a new electronic cell getting filled. Okay, so as you go in a period, the number of cell will remain the same, but as the period number will increase, okay, the number of cell will also increase. Okay, how many elements are there in the first, second, third, and fourth periods? So here you can see in first, second, third, and fourth periods the number of elements are not same. Okay, so in first period we have hydrogen and then helium. Okay, likewise in second period we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Okay, then in third period sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. Okay, that means in second and third period the number of elements are same, but in fourth period we have some additional elements like potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, gallium, germanium, arsenic, selenium, bromine, and krypton. Okay, the number of elements in fourth and fifth period remains the same. Okay, so let us see what is given in the book here. Fine. We can explain the number of elements in these periods based on how electrons are filled into various cells. Okay, so if suppose you have to find out why different periods have different number of elements, okay, the reason is here, and the reason is based on how electrons are filled in the various cells. You will study the details of this in higher classes. Okay, when you will go in class 11th, a lot of things you will come across in inorganic chemistry. Recall that the maximum number of electrons that can be accommodated in a cell depends on the formula 2n square, where n is the number of the given cell from the nucleus. Okay, so this 2n square formula I already have given you in while we were discussing chapter 3. Okay, so once again let me say you, okay, that the total number of electrons, okay, can be filled in any orbit or in any cell is given by the formula 2n square, where n is the number of orbit. Okay, for example, it's given here for K cell. K is the first cell. Okay, so the maximum number of electrons filled here is 2 into 1 square, that is equal to 2. Okay, that means in first period, okay, in all the elements of first period, okay, there will be 2 electrons in the outermost orbit maximum. It can be empty, it can be 1 or maximum of 2. Okay, likewise the elements of L cell, okay, in the outermost orbit of L cell elements, there will be a maximum of 8 electrons occupied. Okay, so it can be empty or it can be 1, 2, 3 up to 8. Okay, likewise for elements whose outermost orbit is M cell, okay, 18 electrons can be occupied maximum. The position of an element in this periodic table tells us about its chemical reactivity. Okay, so based on the arrangement of elements in the periodic table, we can also say, okay, that what will be the reactivity of these elements. Okay, in chapter 2 and chapter 3 we have seen that how different elements, metals, non-metals, reacts with acids, bases, okay, then oxygen, okay, and there we have seen a lot of different types of reactions. Okay, then here we will study that what is the reason of the reactivity of elements. Okay, why one element is more or less reactive than the other element. As we have learned, the valence electrons determine the kind and number of bonds formed by an electron. Can you now say why Mendeleev's choice of formulae of compounds as the basis for deciding the position of element in this table was good one? Yes, really it is, because it gives us the basic thing, and that is the reactivity series also. How would this lead to elements with similar chemical properties being placed in the same group? So you will be amazed to know that Mendeleev, when he has formulated this table, okay, uh, it was found out that in his table it was found out that what may be the reactivity series. Okay, and he tried to make his table based on the oxides and hydrides. Now coming to section 5.3.2, that is trends in modern periodic table. Okay, section 5.3.2, that is trends in modern periodic table, will be seen in the next video because this needs a special attention. Okay, so I'm ending our today's video tutorial here. I hope you have enjoyed it. If you have any question to ask, if you have any doubt, any queries, you can type your question in the comment section of this video. Okay, and once again I request you all to please subscribe and hit the bell icon for all. Okay, and like it and share it among your friends. Okay, and on every Sunday we will have questionnaire session which will be uploaded later. Okay, so till my next video, take care of yourself. Bye bye.